Hello friends, warm welcome in this video that is the uncompetitive inhibition. Friends, in the earlier video, you have learned what is a competitive inhibition. There we have seen the inhibitor actually competes with the substrate for the binding site. Now we will learn the another type of inhibition that is the uncompetitive inhibition. So what is the meaning of uncompetitive inhibition? Uncompetitive inhibitors bind only to the enzyme substrate complex and not to the free enzymes. Substrate binding could cause a conformational change takes place in the enzyme and reveal an inhibitor binding site, or inhibitor could bind directly to the enzyme bound substrate. In neither case does the inhibitor compete with the substrate for the same binding site. So the inhibition cannot be overcome by increasing the substrate concentration as we have seen in the competitive inhibition. Both Km and Vmax are altered, but distinctive kinetic patterns emerges under steady state conditions. Let us consider the simplest situation. Enzyme plus substrate gives enzyme substrate complex, which again converts into enzyme plus product. Now if we add inhibitor in the enzyme substrate complex, then it will form ESI complex, that is enzyme substrate inhibitor complex. And by removing inhibitor from this complex, we will again get enzyme substrate complex. In this case, ESI is a dead end complex and the Ki is the inhibitor constant, where Ki is equal to concentration of enzyme substrate into concentration of inhibitor divided by concentration of enzyme substrate inhibitor complex. So for this system, the equation will become like this if we put the value of E. So total enzyme concentration, that is E0, is equal to concentration of E, that is the free enzyme, plus concentration of ES, that is the enzyme substrate complex, plus concentration of ESI, that is enzyme substrate inhibitor complex. Now we know that the Ki is equal to concentration of ES into concentration of I divided by concentration of ESI. Therefore, if we put the value of ESI by changing the value of Ki, then we will get the equation concentration of E plus concentration of ES plus concentration of ES into concentration of I divided by Ki. Now, if we take common ES from these two equations, then we will get concentration of E plus concentration of ES in bracket 1 plus concentration of I by Ki. Therefore, the free enzyme will equal to concentration of E0 minus concentration of ES in bracket 1 plus concentration of I divided by Ki. Under steady state conditions, as we have seen previously, concentration of E into concentration of Es divided by concentration of Es is equal to Km. Now if we substitute the value of concentration of E as we have calculated here, then we will get rate of reaction, that is V0 is equal to Vmax divided by concentration of initial substrate divided by concentration of initial substrate into 1 plus concentration of initial inhibitor divided by Ki bracket close plus Km. Now if we divide throughout this equation by 1 plus concentration of I0 divided by Ki, we will get rate of reaction is equal to Vmax into concentration of S0 divided by 1 plus concentration of I0 divided by Ki whole divided by concentration of S0 plus Km divided by 1 plus concentration of I0 divided by Ki. So thus for the uncompetitive inhibition, the apparent Vmax, that is V prime max, is equal to Vmax divided by 1 plus concentration of I0 divided by Ki, and apparent Km, that is K prime m, is equal to Km divided by 1 plus concentration of I0 divided by Ki. Similarly, if we solve the equation, then the Lineweaver equation will obtain, which is equal to 1 by V0 is equal to K prime m divided by V prime max into 1 by concentration of S0 plus 1 by Vmax. And the slope of the Lineweaver plot under the presence of uncompetitive inhibitor will be K prime m divided by V prime max is equal to Km divided by Vmax into 1 plus I0 concentration of I0 divided by Ki divided by 1 plus concentration of I0 divided by Ki. So it is equal to Km divided by Vmax. So in other words, the slope of the Lineweaver plot is not altered by the presence of an uncompetitive inhibitor, but both intercept changes. As before, the inhibitor constant Ki can be determined using secondary plots for uncompetitive inhibition. So this is the Lineweaver equation in the presence of uncompetitive inhibitor. Here both the Km and Vmax get altered. This plot shows the effect of several inhibitor concentration at fixed enzyme concentration on the Lineweaver plot. The value of inhibitor constant Ki can be determined using the secondary plots. For uncompetitive inhibitors, 1 by V prime max is equal to 1 by Vmax in bracket 1 plus I0 by Ki, and 1 by K prime is equal to 1 by Km in bracket 1 plus I0 by Ki. Hence plots of 1 by V prime max against concentration of I0 and 1 by K prime m against concentration of I0 are linear. The intercept on the I0 axis giving the Ki in the both plots. Uncompetitive inhibition of a single substrate enzyme catalyzed reaction is a rare phenomenon. One of the few possible examples known being the inhibition of aryl sulfatase. The enzyme aryl sulfatase carries this reaction like this. Here, the sulfate group of this position get removed and we will get this product. But the aryl sulfatase enzyme in the presence of hydrazine forms enzyme substrate complex which then binds to the hydrazine and no further product will obtain. Similarly, the alkaline phosphatase enzyme catalyzes this reaction, that is, it converts phosphate monoester into alcohol and phosphate. But however, in the presence of phenylalanine, the enzyme substrate complex will bind with the phenylalanine, the product will not form. However, uncompetitive inhibition patterns are seen the two substrate reactions, and this may help in the elucidation of reaction mechanism. So in next video we will learn what is a non-competitive inhibition. Thank you.